In lesson 5.3 part 2, we are going to be taking a look at some trapezoid properties. I don't have a warm-up for us today, so we are just going to go ahead and get started. Our key term is isosceles trapezoid, and this should already be on your vocabulary sheet from chapter 1, but an isosceles trapezoid, or actually maybe even chapter 4. An isosceles trapezoid is a trapezoid where the two non-parallel sides are congruent. So recall that a trapezoid is a quadrilateral with one pair of parallel sides. In an isosceles trapezoid, these two segments, the two non-parallel sides, they are congruent. I mean, you can have trapezoids that look like this, right? So these two segments are clearly not congruent. You could have a trapezoid where this maybe is shorter and this segment is much longer. But this is what an isosceles trapezoid is, because we are going to look at an isosceles trapezoid. So first of all, we're going to make a generic trapezoid. And we, instead of constructing parallel lines, which we did not do as part of our summer geometry course, we are going to use a ruler, otherwise just known as a double-edged straight edge. Now, the two segments, the sides of the ruler themselves, are parallel, and so we are going to use that to make our parallel, okay? So we're going to draw these two segments, and then we are going to make them unequal length, and then we're going to draw the non-two parallel sides connecting them to make a trapezoid. So these are not going to be congruent, okay? All right, and now what we're going to do is we are going to take our protractor and we are going to find the sum of the measures of each pair of consecutive angles between the parallel sides. So remember, consecutive is one after another. So these two angles are consecutive, these two angles are consecutive, etc. But we are finding the consecutive angles between the parallel bases. So we'll sum these two angles here, and we will sum these two angles here. So I'm going to go ahead and measure these angles, but pause the video. That way you don't have to watch me measure all these angles, and then we'll come back and take a look at the sum. All right, I went ahead and I measured my sides, my angles, excuse me. I want you to notice that I did have to extend some rays. So as I was using my protractor, I couldn't quite read where this ray was coming out of the top of my protractor, so I did have to extend that. All right, so if I have a 135 degree angle plus a 45 degree angle, I notice that their sum is 180 degrees. And then this angle is 103, this one is 77. I also notice that their sum is 180 degrees. So hopefully you noticed the same thing. Now maybe you got like 179 or 181, but if your measuring was accurate, you should get somewhere close to 180. And so that means the consecutive angles between the bases of a trapezoid are supplementary. Now, we are not going to prove this today, but can you ask yourself why it's true? I'm going to give you a hint. It has something to do with our alternate interior angles. And so, like, remember, if these are our parallel lines, we have a set of alternate interior angles right here that are congruent, and then we have a linear pair, so that might give you a hint about why that is going to be true. Okay, so now we're going to take a look at some isosceles trapezoids, right? Like kites, isosceles trapezoids have one line of reflectional symmetry, and through what point does the line of symmetry pass? And it passes through the midpoint of each of the bases. So you can imagine drawing a line. You can imagine drawing a vertical line through that and folding that trapezoid on top of itself. So once again, we are going to use both sides of our straight edge to draw parallel lines. And we're going to need to make our compass to make the rest of this isosceles trapezoid. We don't want to use our ruler. I'm going to get my compass, so I have to pause for a sec. Okay, so to make this an isosceles trapezoid, here is what I would do. I would start at the top base because I think that's kind of easiest. And I would mark the two endpoints of the segments. And then I want you to notice that my bottom base is a little bit longer. It doesn't have to be that way. Like you could have the top be longer than the bottom. But remember, we don't want to make like a rhombus or something like that. We want to make sure it's a trapezoid. And so what I'm going to do is I'm going to go ahead and take my compass. I'm going to put my stylus on that top endpoint. And I'm just going to extend my compass so that it might go a little bit beyond here, but I don't want to swoop this way. That would make, that's going to like make a parallelogram. I'm swooping to the left. All right, and you can see it just barely fits. If it didn't, if my arc strike did not intersect that other base, then I would go ahead and extend this segment down here. And then I do the same thing on the other side. I'm not changing my compass setting because I want those two segments to be the same length. And now that they are the same length, I can go ahead and connect them. And now I know that I have an isosceles trapezoid. So I've got that, congruent, and those parallel. Okay, so now we're supposed to measure each pair of base angles. Okay, so the base angles are the angles formed by one of the parallel sides and then the other two non-parallel sides. So these are a set of base angles and these are a set of base angles. So let's go ahead and compare that to measure them. Again, I'm going to pause my video and do my measuring and then I'll show you the results. I have measured my base angles and I want you to notice that my base angles are congruent. Does this surprise you, or did you kind of intuit that this would be true? And maybe ask yourself why you think that would be true. So what do you notice about the base angles of each trapezoid? They are congruent. And so the base angles of an isosceles trapezoid are congruent. And then for our last conjecture, we're going to go back to this isosceles trapezoid and we are going to draw, I like the clear ruler, the clear straight edge. We're going to draw the two diagonals. All right, and then I am going to compare their lengths with my compass. So I'm just going to set my compass, set the distance to one of the diagonals, and then I feel like this diagonal is not quite long enough, or maybe I made this one too long. I have to say, it doesn't look as perfect as I wanted it to be, but they are congruent. The diagonals of an isosceles trapezoid are also congruent. Let's take a peek at some example problems. So for this first one, we have a figure where one of our base angles is 56 degrees and we have an isosceles trapezoid and we're asked to find y over here and x over here. So we know that the base angles in an isosceles trapezoid are congruent, so that if this is 56, then y must be 56. And then we also know that the consecutive angles between the two bases in any trapezoid, not just an isosceles trapezoid, are supplementary. So again, please feel free to use your calculator, but I'm just going to go ahead and do this by hand. Are supplementary, so I know that x has to be 124 degrees. For this next one, we have a coordinate geometry.